Hello everyone, welcome back to my YouTube channel. My name is Chemist David Ayodele. I'm your host on this channel, and today we'll be looking at JUPEB Chemistry Practical 2024 coming up next month, maybe later this week on 2nd of August. Alright, if you're a student and you are sitting for JUPEB Chemistry Practical 2024, I got your back. This is an opportunity for you to quickly do your final revision for the chemistry to be able to pass your exam excellently well. The meaning of JUPEB is Joint University Preliminary Examination Board. Alright, okay. Let's look at what we have in store for us today on this practical. Quickly, the acid given this year is going to be hydrochloric acid, 15 cm³ to be dissolved in 1000 cm³ of water, and base is sodium trioxocarbonates 5.4 gram. This area concerns the instructors, okay, be it lecturer, be it students that are going to prepare, be it lecturer, be it instructors that will prepare this practical for JUPEB students. So you actually need this aspect to know how to actually calculate or to arrive at your expected titer value. So let's quickly use the dilution factor. Dilution factor is C1 V1 equals to C2 V2, initial concentration, initial volume, final concentration, and final volume. So from here, from stock preparation of stock solution of HCl, we have 11.6 mole per dm³, giving value of initial volume 15 cm³ of acid. You can see there, and we are looking for the final volume of the base. All right, of the acid, right? Looking for the final volume of the acid. Now V2 is in 1 dm³, which is 1000 cm³. Okay, I'm going to substitute correctly. Look at my substitution here. Then I have going to make C2 the subject of formula. Then I have my final answer here to be 0.174 mole per dm³ of acid. This is my conc of acid in mole per dm³. All right, so I have my base to be Na2CO3. When I multiply that, the molar mass of that, I'm going to have 106 106 gram per mole. 106 gram per mole. Now, using this formula, conc in mole per dm³ is equal to conc gram per dm³ over molar mass, and we will get the value, the CB of my base. 5.4 divided by 106, I have 0.0509. Hope you are following. All right, the equation for the reaction is hydrochloric acid plus Na2CO3 give us sodium chloride, hydrogen, water, and carbon dioxide liberated. Let's use this one to get our volume of acid. So our Ca gotten from above, Va you can see it. So we are looking for Cb, we have it already. For this practical, I'm using 25. In your school, maybe you are using 20, no problem. The volume of the number of mole of acid, you can see there 2. The number of mole of base is 1, you can see it. So let's substitute correctly. When we do that, we have this. Remaining left it our Va. We are going to make Va the subject of formula. Make this a formula. You have this. Now this is going to be our volume of acid you're going to use throughout this practical. Please take note. This is going to be our volume of acid, the calculated volume of acid that is going to be used throughout this practical. I have 3 examples for us to quickly go through together and see how we can well prepare for the examination. All right, let's look at example 1, titrations. You are provided with the following solutions. A is hydrochloric acid of unknown concentration, while B is 1.32 gram of sodium trioxocarbonates for in 250. Indicator is messy orange. Procedure: pipette 25 cm³ portion of solution B into the conical flask. Then add 2 to 3 drops of methyl orange indicator. Calculate again solution A, which is HCl in the breath. Record your titer value. Repeat the titration 2 or more 3 more times and find the average titer value. So the first question is to write a balanced chemical equation for the reaction. Then which two processes have occurred in the above reactions, and from your results determine the uh, number of mole present in cm cube of solution B and the molarity of concentration of A, the mass of NaCl produced in the reaction, and the volume of CO2 liberated during the titration. And these are the parameters given. So let's quickly look at our calculated titration. This is how our table will look like. These are rough here, first, second, and third. Okay, for this experiment, I'm going to be using these two values because they are concordant. Okay, I can as well use the three values. They are also concordant. Okay, so 14.60, another 14.60 is a good value for me to be used. All right, so look at the 14.6 plus 14.6, giving me 29.2 divided by 2. I have my final answer to be what? 14.6. Remember, I told you the calculated value is what I'm going to be using throughout this calculation. So first thing, say write a balanced chemical equation. Look at my balanced chemical equation here. Okay, with my state of matter. Okay, with my state. The next thing, which two processes have occurred in the above reaction? A reaction between number one, a reaction between acid and trioxocarbonates has taken place. And number two, a titration process occur when A and B, which led to the determination of volume of acid used immediately when the color change. Okay, some other observation that you can see, please, you can add to it. We are learning together. Question C. From your result, determine the number of mole present in 25 cm cube of solution B. Remember, in solution B, you are given 1.3 gram, all right, in 250. You're going to convert that one to what? 2 gram per dm cube. We must do that. So all of this explanation, look at what I've written here. In converting, you're going to have 5.28 gram per dm cube. Are you getting that? Then you quickly convert, you quickly calculate the molar mass for sodium trioxocarbonate. That's 23 times 2 plus 12. That's the value of carbon, plus 16 times 3. Then you move from there to the total. You can press your calculator for that. You're going to have 106 gram per mole. Remember, your unit is very, very important. Your unit is very, 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 very important. Okay. All right. Now, when you do that, bring in your formula, which is conc mole per dm equal to conc gram per dm cube over molar mass. Then you have the conc mole per dm cube of B. But that's not what we are asked. We are actually asked to calculate the number of mole. And the formula for calculating the number of mole is going to be conc amount in mole equals to conc in mole per dm cube multiplied by volume over what? Over 1000. Remember, our volume is of B is going to be 25. Your own might be 20, 25. That's the volume of the pipette. So let's take note. All right. Now, looking at this, you can see there, multiply this by 25 equals to this. So my amount in mole of B is 0.01245 moles of B. So that's correct. That's correct. Now, what's the next question? The next question now is what's the molarity of A? The molarity of A, we can use Cavana for it. Okay, acid and base, remember our mole ratio is 2:1. So I'm looking for Ca. I have my Va to be 14.6. That's calculated value from the table. I have my value of base to be 0.098, and my pipette value is 25 cm cube. So I substitute all of that. Then I make Ca the subject of formula, then I have my final answer to be what? 0.17 mole per dmq. Hope you are enjoying the class. Hope you are following me. Just follow me closely, you will get it. I know you will pass your exam in flying colors. And that's what this channel is all about. It's outstanding channel that give outstanding information about chemistry. All right, that's our niche for now. Now, the mass of the sodium chloride produced in the reactions. Okay, this one is going to be especially from the balanced chemical equation. All right, our equation is already balanced. The mass of the mass of sodium chloride produced in the reaction. Okay, it's going to be from the balanced chemical equation. So the molar mass of sodium chloride is 23 plus 35 is 58 point what? 0.5. Now, when you go back to your equation, you see is 1 mole of sodium trioxocarbonates produce 55 gram of this. Now, the mole that we calculated above, remember, which is 0.1245, now be going to x. So when I cross multiply that value, then I'm going to have something like this. So the mass of sodium chloride is going to be 0.0728 gram of sodium chloride. Are you following closely? Okay, keeping more interesting, right? Getting more interesting. Good. Now, lastly, as we round off these questions, so that we can not waste our time, is what is the volume of CO2 liberated during titration? Also from the equation. So we can actually relate this. 1 mole of sodium trioxocarbonate to 22.4 dmq of CO2. It's as STP is given. And this mole that we have, 0.01245 mole of this, will cross multiply, will give us our final answer, 0.0279 dmq, or case may be you might want to convert it to cmq. You just multiply by 1000. Okay, that's for question number 1. Question 2. You are provided with the following solutions. A is a solution of hydrochloric acid contains 0.25 mole in 500 cm³ of solution. While B is a solution containing Na2CO3. Put A into the burette and titrate the given 25 portion of B and using 2 to 3 drops of mercury indicator to the same titration mixture in the conical flask and continue your titration until the end point is reached. Record the volume of A used at the end of the point of meteorite indicator. Then repeat the same titration procedure 3 times. Then determine the average volume of acid used for neutralizing sodium trioxocarbonate 4. In other words, we have to find our VA. Okay, that's not a big deal. You can do that. Then this is the balanced chemical equation given from the information provided and your results. So calculate the concentration of sodium trioxocarbonate, all right, in mole per dm cube. Then concentration of sodium top in gram per dm cube. Okay, let's quickly do that. Can we undo that together now? Okay, no time to waste. Now, this is how our table is going to look like. Okay, our table is the same table we are using this value. Okay, now the average volume of acid used for neutralizing is what? Is this. Can you see I picked 14.60 plus 14.60 divided by 2 equals to all of that, and I have 14.6 as my average value of the acids. The concentration of Na2 mole per dmq. I'm going to do all of that. Remember, I'm giving mole. See my mole. This is 0.2 moles. Okay, moles. This is moles. Equals to concentration of A mole per dmq multiplied by 500 is given. All right. When you do all of that, you have 0.5 mole per dmq of A. So we can now use that to calculate the conc that we need. to calculate the conc of B in mole per dmq. Okay. All right, look at conc of B in mole per dmq now. Use this same equation. Then you have this as we obtained. These are VA 25. Basically, sort of formula. Then we arrive at 0.146, which is our conc of B. All right. Now let's look at conc of B in gram per dmq. Okay, we don't have it in mole per dmq. You cannot get it in gram per dmq. That's why we go through all of this. Can you see it now? All right. All right. Let's look at that. And so before we do that, we're going to have our molar mass to be calculated, which is C106 gram per mole. All right, look at the formula we're going to use. Count of B in mole per dmq in gram per dmq over molar mass. So when we do all of that, we substitute our value, get our value, and we have 15.4 gram per dq. Guys, are you following? Are you following? If you are following, just try and encourage your brother. Okay, just give this video a subscription button. Click that notification bell and subscribe to this channel. God bless you. Now let's quickly look at the last question, which is the wrap up of this particular titration for JUPEB rather, Chemistry Practical 2024. You are provided with the following solutions. A is 0.1 of HCl and B is this indicator, methyl orange indicator. It's supposed to be A here. So procedure: pipette 25 cm3 portion of solution Z. Okay, that's the base into a conical flask. Okay, this is our B. Remember, add 2 to 3 drops of methyl orange indicator. Titrate against a solution A. That's our A. So don't be confused. I'm using A. I'm using B. You know what I'm doing. In the burette, record your theta value, repeat the titration 2 or more 3 times, and find the average theta value. Number one question is write a balanced equation for the reaction. Then from your results, determine the number of mole of Y, that's our A, and the concentration of what? Of anhydrous Na2 in B, and in gram per dmq also in B, and lastly the numeric value of N in the formula B. Again, our table is this same table I told you we have been using. So the first question is to ask is to what? Is to get the value of what? Of the VA. Then the first question is another question, say write a balanced chemical equation. I beg your pardon, I'm supposed to be X C 2 X here. So ignore this. Let's ignore this. So it will be 2xcl. Okay, for the equation to be properly balanced. So that the number of moles of Y. Okay, I told you Y is what? Y is our A. Y is our A. So let's quickly use that formula to calculate Y. Amount mole of Y, measure of Y, mole per dmq, multiplied by volume in days. So the value given is 0.1 multiplied by our table of value, which is 14.6. So you have this. So this is our A, 0.0146 mole per dmq of A, which is same thing as Y. So let's go to the next one. Next one is to calculate the concentration of an ideal solution in Z. Remember, our Z is what? Is B. We are going to use Carbana. CAVA, CBVB over equals to NA over NB. And let's substitute the value of acid, the VA. We are looking for CB, all of that. We have that. So when you calculate that, you are going to have 0.1 multiplied by 14.6 times 1 divided by 25 of this. Then you have this of B. Remember, it's B we are calculating. Okay, B is our Z. Okay, now how can you take this one to gram per dmq? You can use our formula. molar mass is 106 gram per mole. Did that before. Conc of B now in gram per dm. Let's multiply molar mass by this. That's what we do. These are value obtained from up, and these are molar mass. So we have 3.09 gram per what? Per dm cube. So the last one is to get our numerics. What is the value of our numerics? That's the last thing we need to get. Let's quickly check it. The numerics of this in the formula. Remember, our formula is Na2CO3 dot NH2O. This N is our numerics. That's what the number we are looking for. All right. But on the question, you are given that 1.8 gram of and is in 250. So we are going to convert it. Okay, we are converting that. You can see it now. And now you should have mastered how to convert gram to DMQ. We have this. All right. Remember, we are dealing with B. Okay, Z is B. Okay, let's find the molar mass. That's what you're going to equate to this to get the value of N. The molar mass is this 7 point, this one divided by what? Mole per dm. We have found our molar mass to be 254.8 gram per mole. So everything now will be equated to 254. So when you substitute the value correctly, you have this. Then you look at it, 46 plus 12 plus 48 in that order, and divided by what? 18. Then you have 8.3. Okay, you have 8. So the value of N there will be what? 8, not 8.3, because it's going to be whole number. But originally, from experience and from what we have, we only have decahydrate. I've seen decahydrate in chemistry, especially for trioxocarbonates. It's supposed to be 10, but it's an experiment. Okay, an experiment, so it is all acceptable. Do well to subscribe to this YouTube channel and stay tuned. We are always here to get your back when it comes to chemistry practical, when it comes to chemistry theory, when it comes to tutorial on chemistry. So you can also call us. Okay, for your holiday lessons, we are available. Okay, see you. God bless you. Online classes, we are also available. Thank you. God bless you. Do have a nice day. Sign out.